All right, so we finished up the was it an email example, or we finished up that portion of it. So I'm going to go to how to do some of this on your calculator, and then we'll do another little thing, and then bounce back to that email example one more time. All right, the binom PDF function calculates binomial probabilities binom PDF of NPX, where N is the trials, like the number of trials, P is the probability of success, and X is the desired number of successes.
I have 4.6.
You have 4.5 too?
Not 4.5, but I have 4.6 done.
Okay. So you just have 4.5. That's all that you need to finish. Okay. Thank you. All right. So this is for an individual outcome. Meaning exactly X successes. Now that's binom PDF, but we also have binom CDF of NPX. And this calculates X or fewer successes in N trials. Watch out for at least X and use complements of 1 minus binom CDF NP X minus 1. Using the normal model for binomial models, requires checking the success failure condition a binomial model is approximately normal if we expect to see at least 10 failures and 10 successes. So n times p is greater than or equal to 10, and n times q is greater than or equal to 10. So we're going back to our email example. Apparently, literally.
Okay.
Alright, so your spam filter, if only they worked as well as we wished they would, only allowed 151 of 1,422 messages through. Is it too aggressive? We have an aggressive spam filter, everyone. It's getting a little crazy. So we're going to check some of our conditions first. All right, what color was I using to do this before? Orange. Just go consistency here. All right, is 1,422 less than 10% of all emails? We're checking to see if this condition is true. This statement should be true if we say the condition is true.
So are we gonna say it's true?
Well, is it? Is 1,422 emails less than 10% of all emails?
I guess.
I don't know
It
how
should
many
be.
are all emails.
I mean, I
Like
myself
every
have,
email
over
ever.
7,000
Oh,
done with
yeah.
emails.
Or even in somebody in like for your own emails, like
Yeah.
you've had way more emails than that in your life, I'm sure.
Yes.
Okay.
Okay. I was like, wait, are we missing a number?
So yes. Is the probability of success constant? We might have to go back.
Yeah.
Probability of success was 9%. Is that constant? Yes.
I don't think it's gonna change.
All right, now we're going to check NP and NQ and see if they are greater than 10. So N times P is 1422 times 0.09. And NQ is 1422 times 0.91.
So what was the question we're asking? We gotta find out if it's like greater than or less than what?
Well, I need to know what they're equal to, and I want to know if it's greater than or equal to 10.
So that one's equal to 127.98.
Okay, so that one's greater than 10.
Yeah.
And the other one is 1,294 .02. Which is
Oh, good.
really
Those
great.
numbers add up. So, both are greater than 10. So that condition is met. So now I'm going to find the mean and the standard deviation. So mu is equal to n times p, which we already found up here, is 127.98. Standard deviation is the square root of NPQ, which is the square root of 1,422 times 0.09 times 0.91. So now I'm looking at the probability of x being less than or equal to 151. So this is P of z less than or equal to the z-score of 151 minus the mean, 127.98, divided by the standard deviation, 10.79. So whatever that number is what we're going to go to our table to find.
What's the formula for z-score again?
X minus mu over sigma. Two point what? 1.3. So we're going to go back to our handy dandy table. Now, I want .13's over here. I want this side of it. So on my table, I'm going to 2.1 and then 0.03. So this is 0.9834. So that means, in conclusion, that there's a 98% chance that no more than 151 are good.
So it's
Means
not-
like all the rest should be spam.
So it's not toothbrush.
Correct. Huh?